Alright, to establish the following identities, what you typically do is start with the more complicated side and write it down, right? And in this case, I think the more complicated side is clear. It's the left side. So I'm going to do this. 1 minus sine squared theta. Just rewrite it. I'm not going to do any work yet. Notice how I do not write the left side. I'm sorry, the right side. Start with the left side. I do not write the right side. I don't write that down because that's what I'm trying to show that this left side is equal to. Right, so I'm going to do some work and hopefully end up with the right side. So what kind of work do we do? Typically algebra and maybe apply some trig identities, okay, which is the first step I'm going to do here. Well, let me take a minute. What do we do first? Right, you look at that and you know, I know that I have an identity for that. So that's often what we do. If we identify something that has an identity, we apply that identity. Sine squared theta is equal to 1 minus cosine squared theta. Okay, so that's one way I could go. The other thing we like to do is add two values together. We have one fraction here and we have this number 1. We could write that over the common denominator of 1 plus cosine theta. That might work as well. But I think the best thing to do is to first apply the identity, because we do that a lot, and then hope that that's going to work out for me. Okay? And after that, I can see I can factor that numerator. And the reason I want to do that, the hint that I'm given, is that if I factor 1 minus cosine squared, I can see there's a common factor now in the numerator and denominator. Right? So I can cancel those guys out. And it's really become much simpler now. So what am I left with? 1 minus cosine theta. And then if we just distribute the negative, we get 1 minus 1 plus cosine theta, which of course will give us our answer of cosine theta. Alright, how about the next one? Sine of alpha plus beta over sine alpha cosine beta equals 1 plus cotan alpha. Sorry about that. Okay. Sine alpha plus beta of sine alpha cosine beta equals 1 plus cotan alpha tan beta. Alright. So to see that, again, I want to start with the more difficult, more complicated side, which I'm pretty sure is the left side again. So I'm going to write that down before I do any work. Cosine beta, okay? And I'm pretty sure where I'm going with this one. I know I have an identity for sine alpha, sine of alpha plus beta, right? We've seen that before. We know it's sine alpha cosine beta plus cosine alpha sine beta, all divided by, and I didn't change the denominator, sine alpha cosine beta. Okay, so it looks like it's a little more complicated. We're trying to simplify. Now, the good thing about these is we're given the answer, right? We know it should equal 1 plus cotan alpha tan beta, so that's a big hint. So I can see where I get that 1 from. If I just break this up, break my numerator up, right, I'm dividing this denominator into both of those terms. So I'm allowed to break it up like this, sine alpha cosine beta divided by itself, and over here it's sine alpha cosine beta. Right? And I can see that sine alpha cosine beta divided by itself is 1, and then maybe we'll do one more step to show where the cotan alpha comes from. That's cosine alpha over sine alpha. And then the tangent of beta would be sine beta cosine beta. Right? And now we can really write our final step, cotan alpha tangent beta.